Alright, rules of probability. We'll go over some of the basic rules of probability. Hopefully you know some of these. So we'll start off with, I guess I'll try type in here. The sum of all the probabilities in your sample space should be 1. Okay, good rule to know. All right, gotta hit a new text box here for a new rule. Rule number 2 is going to be about disjoint and mutually exclusive. So, 2 events are disjoint. And another word for disjoint is mutually exclusive. If they have no outcomes in common. Okay, so let's think about, I'm going to roll 1 die. So I'm going to call event A, roll a die, and the top pip is a, is a 2. Okay. I'm going to call event B, I'm going to roll a die. And I'll get an odd number. Okay. Are events A and B mutually exclusive? Yeah, because the outcome for event A, the outcomes for event A is just a 2, and the outcomes for event B is 1, 3, and 5. So they don't have any outcomes in common, so they are mutually exclusive. Okay, so now we'll go with the rules about that. All right, if 2 events are mutually exclusive or disjoint, the probability that one event or the other will happen, and I'll call this A or B, is the probability of event A happening plus the probability of event B happening. We also write this out as, come on, give me a pen, probability of A union B. And that means the same thing as the probability of A or B. Union means or in set theory. So that big U means union, and it means or. The U, the big, it's like, it's a union symbol in set theory is what it is. Yes, sir? The union of 2 sets would be all of the outcomes of the 2 sets. So the union of set A and B, I'm going to have to do this, in handwriting. The union of set A and B is all the outcomes is 2, 1, 3, and 5. So A or B is 2, 1, 3, or 5. Okay? So the probability of A union B, the probability of A or B, is the probability that event A happens plus the probability that event B happens. So what is the probability of event A? And B? That's 4/6 or 2/3. This rule only works for disjoint. Okay. Let's move on to another rule. And that'll be the complement rule. The complement, L-E-M-E-N-T, of an event is the event not occurring. Okay? So the complement of an event is the event that the event doesn't occur. So the complement of A, I need to write this in pen here, sorry. So event A was rolling a 2. I call the complement of A with a superscript C. That's the complement of A. So the complement of event A would be rolling a 1, a 3, a 4, a 5, or a 6. So the probability of the complement of A is defined as 1 minus the probability that the event occurs. Well, A complement was 1, 3, 4, 5, 6. That's 5, 6. And 1 minus 1, 6. Oh, probability is 5 out of 6. So there's the complement rule. And let's see. Should do some fancy things here. Or we probably should move on to another rule. And that's going to be a definition of intersection. So that will lead us into independence. So I've got A with a U here, and we can have A with an upside down U here. So this is a new thought here, new rule. And A upside down UB is A intersect B, also known as A and B. So if I say A and B, that's going to be the event that both A and B occur. That's going to be the outcomes in common for A and B. Yep. Okay. So, oops. Come on. There we go. So, are there any outcomes in common? So their intersection is called the empty set, a 0 with a line through it. So the probability of A intersect B, or the probability that event A happens and event B happens, that we get a 2 and an odd number, is 0. So if they're disjoint, guys,